Alright folks, we're going to do more with angles and arcs today. So you should have been handed out an activity sheet. You're going to need your geometer for this, and then go ahead and grab out a calculator for later on when we get to our practice. Okay, while you're doing that, I'm going to go over some vocab from what we did last time. So we talked about central angles. Okay, so this example of the circle on the right-hand side of your sheet is a central angle. And that's because we have this SPB where the vertex P is the center of the circle. So we know a central angle is happening when, just write some quick notes to the side here, the vertex of the angle is the center of the circle. Now another thing that is happening is with the sides. The sides of this angle are two of the radii. Okay? So we can say sides are radii. Okay. Today we're going to focus on another type of angle called an inscribed angle. Okay, so that word in is dealing with an angle inside the circle still. Okay, that's important because we're going to talk about some other angles next time. So an inscribed angle, not only is it inside, but we're going to focus on that vertex again. The vertex is a point on the circle, or on the edge. So the vertex of the angle for this one is on the edge. Okay. And then the sides can either be a chord, like RT is, or it could be a diameter, like RD is. Okay, they could both be chords, but we can't have them both be diameters. Okay, so sides are chords, usually. But could be diameter. And we're going to do some measuring. Okay, we're going to talk about the relationship between these two angles so that we can use the relationship when we deal with arcs. Okay, so to start out with, as a reminder, when we measure with our protractor on our geometer, we want to make sure our angle looks kind of like an L, where our vertex is in the center, and whatever's facing on the bottom to the right is pointing at 0. Now that means our sides of our angle have to be long enough for us to measure accurately. So I'm going to start you out here, set up for success, by extending the sides of our angle. So just grab the straight edge, the side of your geometer, and we're going to line it up with our two sides and just extend them out. We're going to do that for the first circle and the second one over here. That way we're ready to move on and answer some questions. Okay. So you're going to be answering some questions regarding the measurement of different angles, and then you're also going to be asked to do some drawings. So what I would like you to do is work with someone or all the someones at your table and answer those questions. We're going to come back together in 5 to 8 minutes and talk over the results you got when you answered those questions. Okay, so go ahead and pause the video and try that now. Alright, when I went ahead and measured DRT, so from here to here to here, I got 38 degrees. And if you're off by 1 or 2 degrees, that's no big deal. If you're off by like 10 or 20 or 30 degrees, that is a big deal. Okay, so you may lay down your geometer and remeasure for me. Then it asks you to draw radius, there's only one, radius QT. So that was just connecting Q to T. And not going past, those are endpoints for a radius, cannot add arrows or go past the circle. And using that, we're supposed to find a new angle, DQT. Okay, so I'm going to change colors here and focus on the angle from D, then Q to T. Well, I thought I was going to change colors. Try that again. Okay. So you may have had to extend out some more pieces there, but that, notice, is the central angle because the vertex of that was the center of the circle Q. And when you measured that, hopefully you got something close to 76 degrees. Okay. And then over to the right picture, we started with the central angle. That was a nice 90 degrees. Hopefully we all agreed on that one. But I asked you to draw point A to the left of P. So you may have gone directly to the left, but you could have also gone up a little bit or down a little bit. And just to show you that, I'm going to draw mine a little bit up. Don't change where yours is. But then it wanted you to connect the A to S first for that chord, and then A to B for that chord. Okay, put some vocab in here from last time as reminders. And ask you to measure SAB, this new angle we just formed. So I'm going to extend that out and that one out. Okay. And that one ended up being 45 degrees. Okay. So hopefully you noticed a relationship here. When you have the central angle, the inscribed angle was half. When you started with the inscribed angle and were trying to get to the central angle, it was double. Okay. I like to use this relationship, the double, because half is, fractions. We try to avoid those. So I'm just going to write it in the terms of the central angle is twice the inscribed angle but these were special. I do want to emphasize that. That's not always true. It's true when they share an arc. So I want you to highlight or darken this. You'll notice that I set up this problem so that the two angles that you were instructed to draw intercepted the same arc. And that's how we're going to use this to answer some questions on your practice today. We learned from last class that if the central angle was 90 degrees, that meant the measure of the arc was 90 degrees. So now that we know about inscribed angles, this being 45, we can get from the inscribed angle to the arc measure using that same relationship of double. Okay. Similarly, if we know that this arc measurement was, what was this, 76 degrees for the central angle, then our arc would be 76 degrees, and I could find my inscribed angle going backwards of 38 degrees from what we learned before. Okay, so we can start with this number and go out to get to the central or to the arc, all the different things. Okay, so we're going to put the ideas from last time and what we just learned about an inscribed angle today. Okay, so I'm going to have you pause the video to make sure everybody gets a practice in front of them so we can take some notes here. Okay, and then I'll continue on. So we already talked about the definition of this inscribed angle. The vertex has to be on the circle, so it has to be on the edge. I like to emphasize that. But the sides are going to contain chords. So that means I could extend this out to be a ray or a line, okay, or I could sometimes, remember, in those special cases, have a diameter as well. Then the arc measure is what we're going to focus on. The arc measure contained by an inscribed angle is going to be twice as the angle that we're working with, and the inscribed angle is going to be half as much. So I'm going to use a visual to kind of go through that. On this first one, we're trying to find the arc measure of AC. If we are given the angle and we want to get to the arc, we're moving outside, and when we move outside, we are going to multiply by 2. So we're moving outwards. So this one is going to be 72 degrees for us. And I do encourage you to go ahead and write that times 2 on your practice. You don't necessarily need to do that on your homework, but when you're looking back, you want to have some good notes for yourself. This one, we're finding the angle N, and we're starting outside. We're moving inside the circle. So this one, we're going to divide by 2 instead. So 62 divided by 2 is 31 degrees. Okay? Remember, when we have 3 letters, that is a major arc. It just means we're going the long way around. So I'm going from QSR. It is still the intercepted arc. Okay, I is still dealing with an inscribed angle across from it because that P is on the edge of the circle. So I'm starting at what I'm given, and I'm moving outwards. So that is going to multiply by 2 and become 226 degrees. It's very big, but also, hopefully you recognize this weird-looking picture. We've got this obtuse angle, 113, and we're covering almost all of the circle there, and all the way around is 360. So it's not surprising that that is so large. Now, here's what I'm going to have you do. I want you to try 4 through 9 with a partner. You can work with everybody at your table if you would like. Okay, I'm going to give you a few minutes here to pause the video and try each of those problems, and when we come back together, I will go through them. Okay. I'm going to put up the answers for some of them here. You'll notice I skipped 6 and 7. I want to talk about those ones together. So check your answers for those other ones first here. Make sure those look good. And then we're going to go through those other 2 problems step by step. So, when we're dealing with arc measures, we talked about this last time, the key numbers that are going to be important to solving stuff is a semicircle is 180 degrees, and a full circle is 360. Okay, so for this one, we are trying to find the measure of angle R, which is an inscribed angle, but I don't have the angle across, or the arc measure across from it. So that means I'm going to need to find it. So, dealing with this arc measure here, we, combined with the 120 and the 140, have a full circle. So I can take 360 and subtract off those other measurements to get what's left of 100 degrees. Now, be careful, that is not the answer, because I want to move inside the circle to find that inscribed angle, so I have to divide it by 2 for a final answer of 50 degrees. Alright, similarly on the next one, I want to find arc MP. Hopefully you're reading closely on that. It did not want MN, it wanted MP. Now, we're going to use the fact that we have a diameter here. So what I want you to do is darken the diameter. You'll know that because it goes through the center from one edge of the circle to the other. And when we see that, that's going to tell you, hey, I may need to use 180 here. So with this one, we know from what we've been talking about today that across from this 31, I can double it to get the arc measure of 62 degrees. And then a semicircle from one endpoint to another endpoint on the diameter is 180. So that means I can take 180 degrees minus that 62 degrees to come up with my answer for this one, which is 118. Okay, so a little bit of thinking for those 2. Okay, speaking of some thinking, number 9 and 10 are some challenge problems that oftentimes show up on standardized tests like the ACT that many of you will be taking next year. So we're going to talk through this one. You'll notice these look a little bit different. I do have angles, but more than one. I have 3 angles that are forming a triangle. So here, we call this an inscribed triangle, or we can say a circumscribed circle. And it's based on where the thing we're talking about is. So inscribed means inside, and circumscribed is outside, like the circumference, okay? So looking at our triangle here, we know a little bit about triangles, just like we know a little bit more about circles. We can use both those ideas to solve this problem. Okay, so it looks like we're trying to solve for x. But when we're dealing with solving for the angles in a triangle, we need to know all 3 of them, unless it's a special triangle like isosceles or equilateral. So here, we only know 2 of them. We're given this x plus 12 and this x, but we don't know this third. That means we can't right now directly add up to 180 degrees. But what we just learned is we can talk about circles and their arcs in a way to figure out angles. Turns out that this WX is a diameter. So just like I did on that last one, I'm going to have you darken it, because that tells us we have semicircles happening. Okay? Along the bottom, this is 180 degrees, and along the top is 180 degrees. Since this y is the angle I don't know right now, this top angle of 180 degrees is actually going to be helpful for me, because that is the intercepted arc formed by this inscribed angle. So if I'm moving inside the circle here, I would need to divide by 2, and that tells me that that is actually a 90-degree angle. And in fact, anytime we have a polygon, or excuse me, a triangle inscribed inside of a circle where one of the sides is the diameter, that side or that angle across from the diameter will always be 90 degrees. Okay? So with that, we have enough information to solve for this. We know that we need to equal the angles to 180 degrees, and then we're going to add up all the pieces. So I've got an x here and an x here, making 2x. And then I've got this 90 degrees I just found, and then it looks like a plus 12 here of 102. From there, it's a regular equation we can solve. We're going to subtract 102 from each side. This 2x comes down. Those cancel out, and 180 minus 102 is 78. Divide by 2 on each side. Those cancel out. We're left with x. 78 divided by 2 is 39. So x is 39 degrees. And that will help us solve, I presume, for the next thing. So it wants us to solve for the measure of angle W, which is this one right here. They gave us the expression. We just have to plug in our x value. So that'll look like 39 plus 12, a nice 51 degrees. All right. I'm going to help you get started on number 10. Okay, that same thing we talked about is happening here. We have 2 of the angles, but we don't have the third. All of these vertices of the triangle are on the circle, which means they all correlate to an inscribed angle. Okay, we don't know S, so I'm going to just highlight this so we can see our inscribed angle. Marks off this arc over here. Because we have RT as a diameter, that is 180 degrees, and S is 90. I'm going to have you take it from there. Pause the video, take 2 minutes, solve for X, and then substitute in to solve for T. Alright, I'm hoping your equation looks something like 6x plus 84, because I've got 90 minus 6, equals 180 degrees. Solving that quickly here, we've got 6x equals 96. Dividing by 6, we've got x equals 16 degrees. And then substituting in over here for t, that's 4 times 16 minus 6, which is 58 degrees. Okay. All right, we've got quite a messy picture here, but what I like to do is actually, before I go try to answer these one by one, is I just read through what they are and locate them. Then I'm going to go in here, not try to solve these one by one. I'm going to go over here and fill in as much as I possibly can that might help me. I do that because I don't want to get stuck in a box where I have to find this one first. Sometimes it's easier to actually find one of these other things. Okay, so I'm going to put a little A, B, C here, and we'll just go put in the picture that we need those things. So the first one is B, D, E. So from B, D, E, since it's an angle, that means I'm putting little a inside here. That's the first thing I'm going to need to find. Okay, then measure of the arc CD is from here to here, so I need this outside. And then DBF is another angle that I'm going to put inside. So from D to B to F is this little corner here is C. Okay, so now I'm going to go back to this picture and just talk about what I know. So the first thing I would like for you to do in any messy picture is if you're given a diameter, highlight it, because that's going to help you. Okay, in this case we are, so I'm going to highlight this diameter from B to F. Why that helps us is it tells us that this bottom arc has to be 180 degrees, and this top arc has to be 180 degrees to get that full 360. And that may help us solve for some problems. Okay? Another thing we're going to do is look at the measurements we're given. So we're given a 23 arc from here to here. I'm just going to mark that off a little bit more clearly. Given a 48 from here to here. And then we've got this 52. So I'm going to start with the 52 since we've been talking about inscribed angles. So we're starting inside. That tells me all the way across from it, I can multiply by 2 to get 104. And I just found one of my answers. And it's part B. So I'm going to put 104 here. It was easiest, in my opinion, to start with that. Okay? So now, I'm going to go to the next one. Next thing it looks like are the angles. So now I'm going to relate those angles back to the arcs they go with. So the angle A is the first one here. And if I am trying to find A, I need the arc across from it. So I have this 48 already given to me. Okay, I'm going to change colors here. And since I have the 48 and I'm moving inside, that would mean I'm dividing by 2 to get 24 degrees. Last one is another angle measure, little c here. So I'm going to need the thing across from it, and I don't have it yet. Okay, so that's going to be my next step. I have to solve for that. And that's where my semicircle is coming into play. So just like we did with the idea of the full circle 360 way at the beginning on, gosh, what was it? Problem number 6 it was. Okay, with that, we want to know that we have 2 other pieces. I'm going to just take 180 semicircle minus those 2 pieces. Okay, to get my missing piece here of 53 degrees. Now, that wasn't labeled with an answer. I need to find C, which is across from it. So if I'm starting outside and moving inside, I'm going to divide by 2. And this one's weird because it's our first odd number we've seen. But we're still going to get a decently nice number. It's going to be a 0.5. But 26.5 degrees, that's as ugly as it's going to get for these answers. Most of the time they will come out nice. Now, if you prefer, kind of like when we were solving for those triangle problems, if you prefer to add these first, that works too. You could take 104 plus 23 and subtract that from 180 instead in one swoop. So 104 plus 23 is 127, and that gives you the 53 as well. Okay, your choice. A couple more problems here, all similar types. We're going to talk about the tangent segment theorem. Okay, so remember that word tangent means touch. Okay, and a lot of times when we were dealing with tangent, they were tangent lines, they had arrows. These we're going to talk about specifically are segments. Okay, so if we have 2 segments from the same exterior point, so my exterior point here is C, and they're tangent to a circle, it says they're congruent. So here's what that means. So there's a lot of fancy things to say, is I've got a segment that touches a circle at one place. I've got another segment that touches a circle at one place, and they connect to the same point. If that's happening, then those segments are the same. And I'm going to have you visualize this with drawing a triangle from that. Okay? Visually, they look the same. Okay, they are. In this case, what I want you to do for work for me is put these tick marks on here to mark you know that they're equivalent. And that those tick marks are going to tell you that we have to set some things equal to each other. So when we see those, it triggers our memory. That's we're going to set up an equation. So our first part is x plus 3. We're setting it equal to the other tick mark of 7. Subtracting 3, x equals 4. Okay. On the other side, same thing. We've got tangent segments meeting at the same point P. So that 12 has to be the same as x. No solving there, just x equals 12. Last problems are going to use that idea of tangent. We've got circumscribed polygons. So again, the polygons are outside the circle. And all of these are tangent points because they touch the circle in one place. And what we're going to do is treat each one of these points as little individual triangles. Okay? With that, we're going to do some tick marks all the way around to start with. So I know that this piece of the imaginary triangle is the same as this piece. These two are going to be the same, but not necessarily the same as up here. And similarly, these two are going to be the same. Okay? Once I have those labels, I'm going to put on the numbers I know. So this was a 13, that makes this a 13. This was a 10, so that makes this a 10. This was a 17, so that makes this a 17. And now I'm going to be able to answer all the questions. Okay? So the first thing it wants to know is x, and that's the full length from this side to this side. That's the 13 and the 10 together. So you're going to add those two numbers to get 23. Similarly, if I need the perimeter of this triangle, I want to add all three sides, which means I need to put together my little pieces. So here I've got 17 and 13 is 30. Down here I've got 17 and 10 is 27. So I'm going to take and just write out, again, you wouldn't necessarily have to write this on your homework, but I do want you to write it for this one. We're going to write out our formula for perimeter, which looks like 30 plus 27 plus 23. Okay? These ones are 50 and 30 more makes my perimeter 80. Okay? I'm going to start number 15 the exact same way. I'm going to imagine my little triangles, and I'm going to put some tick marks on. 1 and 1, 2 and 2, 3 and 3. Okay, so I switched it up where, just to show you, it doesn't have to be the tick marks 1, 2, 3, like smallest, medium, and large. It doesn't matter. You just have to make sure the two sides that meet are the ones with the tick marks that match. Okay, from there we're going to fill in what we know. Okay, so I know that this 14 can go here, and I know that this 18 can go here, and this x can go here. So what I just did for myself is I really set up an equation. If I'm going to solve for x, I need to use the idea that I'm given this full length is 26, and that's 18. So putting those together looks like x plus 18 equals 26. I've got to subtract that to get 8 for my x. Once I have that, I can put it here and here to finish up this problem. So I already know that 26 is my total here. I want to find the totals for all the sides. Okay, so there's one of them. Put it outside here so they're all consistent. Then over on this side, we're going to add those as well. 14 and 8 is 22. And then over here, 18 and 14, 32. And we're going to write out our perimeter equation. It doesn't matter what order you write these as well. 26 plus 22 plus 32. Type the whole thing in your calculator, and we get 80 again, which was just coincidental. It's not always 80, I promise. Okay. Your homework should look very similar. Please use your notes, work hard for the rest of the period, and get that done.